So the next one on our list would be the 30, 60, 90 triangle, another must know, and a variety of questions we can ask on that. And, a lot of these subtopics we'll do further lessons on in the very near future. But the ratio for the 30, 60, 90 is x 2x, x root 3. For the 45, 45, 90, x, x root 2. So the thing about special triangles is that you'll only be given one side. So if you're given one side of a right triangle, maybe you can wonder if that's what's going on here. In terms of remembering, the one on the right is a little easier to remember. The one on the left is a little tougher. Maybe the memory tip here is that, we're going to know that the hypotenuse is the large one, 2x, right? But if you can remember that 60 is across from x root 3, you'll have a major leg up on remembering this. So one question type would be one where we find out that one of the sides is 10. So now if that one side is 10 and there's an x ratio, then we may double it up and get 20 and go ahead and multiply by root 3 and get 10 root 3 here. Another thing to look out for is they'll often use the letter x in a problem like this because they want to kind of confuse the ratio letter that you're also using. If you know it's x2x and x radical 3, and the one that you normally label as x radical 3 happens to be labeled as x in the problem, then there's a nice easy way around that. You can just simply label them b 2b and b root 3, problem solved. And another major question type that you might get from this would be, we are given the three angles of a triangle, or actually the three sides of a triangle, apologies, in any kind of way, and we find out that they are in a certain ratio. So for instance, 200c, 100c, and 100c root 3. So here, I'm being told that my sides are in a ratio of x to 2x to x root 3. And so therefore, I am responsible in this situation for knowing that this angle would be the 30 and this angle would be 60, whether that's in degrees or radians. Just so many ways that they can present this. And one more quick way, you can tell this is a more important topic than the rest. I'm almost sensing it from the way I'm talking without realizing it. But one question would be, what's the area of a square with a diagonal of 5, let's say? So what's the area of a square that has a diagonal length of 5? Well, if we draw that out, a very important sort of iteration of the special triangle rules is to say it in this sense. Any isosceles right triangle is a 45, 45, 90 triangle. So any isosceles right triangle, and these are isosceles because it's a square, so these sides are congruent, and it's a right triangle because the square provides the right angle. So now we know the sides are in the ratio of x, x, x root 2. And if the diagonal is 5, then that's 5. So using this, and we will not refer to calculator guy here and actually solve this in the interest of time. But from here, we have enough information to go ahead and say, well, if x root 2 is 5, we're able to solve for x. Once we have an answer for x, the area of a square is side squared, which is basically just length times width, but the sides are the same. So you can multiply whenever you get x, you do x times x, and that would give you the area of the square, and we'd be done. Lots of different ways that you can use special right triangles, maybe one of the top 5 things you'd want to be good at before heading into an ACT math section.